Hi, in this video, we're going to look at differentiating the natural log of x. In example 1, we'll look at proving the derivative, and then we'll use the chain rule to evaluate more complicated derivatives. And you can download this PDF from my website if you want to work along with me. So we're given that y is the natural log of x, and we want to prove that this is dy by dx. We can write dy by dx as 1 over dx by dy. And to find dx by dy, we can make x the subject of this equation. We can raise e to the power of both sides. So e to the y will be e to the natural log of x. And then the e and the natural log will cancel. So we have e to the y is equal to x. And when we find dx by dy, this will differentiate onto itself, and we get e to the y. So we can substitute that into here. So dy by dx will be 1 over e to the y. And we know that y is the natural log of x. So dy by dx will be 1 over e to the natural log of x. And again, this e and the natural log will cancel. So dy by dx will be 1 over x. And this is the proof of that derivative, okay? This is a really easy thing to remember, but it's good to know where it comes from. In example 2, we're going to look at differentiating with a natural log using the chain rule. So in example 2, we're given that y is the natural log of 4x squared. And we want to work out dy by dx. We know that if y is the natural log of x, then dy by dx is 1 over x. The problem we have is that we have a natural log of 4x squared. This derivative only works if we're finding the natural log of 1x. So we can use the chain rule. We can say let t equal 4x squared. Then we'll have y equal the natural log of t. And we know that dy by dt will then be 1 over t, which is 1 over 4x squared. But what we want is dy by dx. What we have is dy by dt. So we need to multiply this by dt by dx, because then the dt's will cancel, and we have dy by dx. And if t is 4x squared, then dt by dx will be 8x. So we can substitute this into here. Dy by dx will be dy by dt multiplied by dt by dx. We can simplify this. The 8 divided by 4 will give us 2. And the x over the x squared will give us 2 over x. So this is our derivative here, 2 over x. We don't need to go through this process every time. All we do is we differentiate this bigger function, so we have 1 over the 4x squared, and then we multiply that by the derivative of this inner function. If we work through question B, and we try to do it in our heads, if y is the natural log of 6x minus 1, then dy by dx will be 1 over the 6x minus 1. That's differentiating this bigger function, multiplied by the derivative of this inner function, so multiplied by 6. So dy by dx will be 6 over the 6x minus 1. Okay? In example 3, we're given this equation for y, and we need to show that dy by dx is this. So we'll differentiate each of these in turn. Because we're going to differentiate, I'll write this 1 over x as x to the negative 1. So dy by dx will be 2 times the natural log of x, so 2 over x, plus we'll bring this power down, this negative 1 down, and we'll get a negative. Then we'll take away 1 from this power, so x to the negative 2. We can write this as a fraction, so dy by dx will be 2 over x minus 1 over x squared. And then we have two fractions, so we need a common denominator. I'll multiply this fraction by x. So we'll have 2x over x squared minus 1 over x squared, and we get 2x minus 1 over x squared, which is what we have here. In example 4, we've been given this equation for y, and we need to show that this is dy by dx. So do you want to give this question a go yourself? Remember to use the rules of logs to think about how we can write this differently. You can pause the video and come back when you're ready. Okay, so welcome back if you had a go. We can split this log up using the division rule. So y will be the natural log of x plus 1 minus the natural log of x minus 2. So dy by dx will be 1 over x plus 1. When you differentiate this in a function, we just get 1 minus 1 over x minus 2. Again, when you differentiate this in a function, we just get 1. So now we need a common denominator. We multiply this fraction by the x minus 2. So we get x minus 2. We'll multiply this fraction by the x plus 1. And we'll have our common denominator of x plus 1 multiplied by x minus 2. We'll expand out this bracket. And then we can tidy up our numerator. These two will cancel. So we've got negative 3 over x plus 1 multiplied by x minus 2, which is what we were asked to show here. Let's try one more question. So do you want to read through example 5 and then try and give a question a go? We know the equation of a straight line is m multiplied by x minus x1, where x is 1. This will equal y minus y1. And to find that value of y, we can substitute x equals 1 into here. So y will be the natural log of 1 plus 1 squared. That's the natural log of 2. But now we need to work out the gradient of a normal. So we'll find the gradient of a tangent by working out dy by dx. This will be 1 over 1 plus x squared. And then we need to multiply that by the derivative of this in a function. So we need to multiply it by 2x. So dy by dx will be 2x over 1 plus x squared. And at x equals 1, the gradient of a tangent will be 2 lots of 1 over 1 plus 1 squared. So 2 divided by 2 will just give us 1. So the gradient of a normal will just be negative 1. So we'll have negative 1 will equal y minus the natural log of 2. We'll expand out this bracket, negative x plus 1, and we'll move the natural log of 2 to the left-hand side. And this will be the equation of that normal. Well, thank you very much for watching. I hope you found that useful. If you want more practice on this topic, you can download the worksheet and view the online lesson from my website, mrmathematics.com. I'll leave a link in the description below.